Alright everybody, I'm here to use trig identities in this video. I'm going to use some trig identities in order to solve some trig equations. So I have got two problems I'm going to do, and there may be more solutions than the ones that are given, and so we're just restricting to looking only at between 0 and 2 pi. Those are the ones I'm going to find. And I've got Desmos here just to verify by looking at where the graphs cross over each other. So the first problem we're going to look at is sine of 3x is equal to sine squared of x. So the first thing that I notice is that 3x is a different input than x, so I'm going to want to try to split it up. And so I can split up 3x as x plus 2x, and then I can use the angle addition formula where that's cosine x times sine of 2x plus cosine of 2x times sine of x. And then I could use that same formula again on the sine of 2x and on the cosine of 2x to break it down so that everything just has a input of x. So cosine x times, well, how is sine of 2x going to look? Sine of 2x is going to be cosine x sine x plus another cosine x sine x. So we can call that 2 cosine x sine x. So that's taking care of this first term there. The second term, I got cosine of 2x. Cosine of 2x is going to be cosine x times cosine x minus sine x times sine x. So we can write that as cosine squared x minus sine squared x times one more sine of x. Okay, so if we distribute things out, we get 2 cosine squared x sine x plus another cosine squared x sine x minus a sine cubed of x. Okay. Now, when I look at this here, I notice that these first two terms are actually like terms. So I can rewrite this as 3 cosine squared x sine x minus sine cubed x. I'm going to do a little bit more because cosine squared, everything else in this problem is about sine, and I know sine squared plus cosine squared is 1. So I can rewrite that as 3 times 1 minus sine squared x times sine x minus sine cubed x. Distribute, and I will get 3 sine x minus 3 sine cubed x minus another sine cubed x. So I guess I end up with 3 sine x minus 4 sine cubed x. Everything I've done so far has been just playing with sine of 3x, but we also know that's equal to sine squared of x. So I'm going to take my answer down here and set that equal to sine squared x. Okay, now I only want to find the values between 0 and 2 pi. What I'm going to do is bring everything over to one side of the equation. 4 sine cubed x plus sine squared x minus 3 sine x equals 0. I'm going to pretend this is like a polynomial. All of those terms have a sine of x in common. What's left over on the inside is like a quadratic equation. 4 sine squared plus 1 sine minus 3. So zero product property says either sine x is 0, or the rest of this junk is equal to 0, which I'm going to factor. So I have 4 sine x times regular sine x. I guess it could be 2 times 2, but I'll try 4 times 1 first. And then I can put a 3 and a 1. So that gives me 3 sine x and 4 sine x. I want the 4 to be positive and the 3 to be negative. So then that works now. If you multiply it out, you'll get the same thing. So this gives me sine x equals 3/4. This gives me sine x equals -1. I can find these answers just based on the unit circle, 0 and pi. I can find where sine equals -1 based on the unit circle, 3 pi over 2. Where sine of x equals 3/4 is a weird one. That's not one on the unit circle. If it was the square root of that, I could do that. That's weird. So maybe I just can't find that answer by hand. I kind of thought this was going to be a solve it by hand sort of problem. Okay, let's try it out. Let's check our work. So maybe I messed up somewhere in this mess of algebra. So let's take a look at the graph. So sine 3x, and make sure it understands what I want. There's sine of 3x, sine x squared. So where do they intersect? They intersect here at 0. They intersect here at pi. They intersect here at 3 pi over 2. And they intersect at 2 other points right there. Those points look like conceivably they could be where sine of x equals 3/4. Let's try regular sine of x, and let's try y equals 3/4. And then let's zoom in, try to get this in a zone where you can see it. So what I want to know is sine of x equals 3/4 is right here, and that is also where the blue graph intersects with the green graph. Now I want you to be careful. Notice that the blue and the green graph are not equal to 3/4. Their y value is not equal to 3/4 at that point. It's just saying that if sine of x is equal to 3/4, based on the trig identities in the algebra we did, the original equation must be equal to each other. Okay, so on that one, we got most of the points by hand. The points where sine of x equals 3/4, you would have to get solving on your calculator. And I'll just point out how you can get those decimals. You can obviously get those decimals by solving by graphing. Oh, that was cool. How'd that happen? Okay, so my stuff all jumped around. That's okay. Let's clear the whole screen then. So let's just focus on one more question before we call this video good. If I have sine of x equals 3/4, and for some reason, imagine in this hypothetical, I have a calculator, but I can't solve by graphing. I don't know when that's ever going to happen to you, but let's pretend that it does happen to you. So then what we know is that we know that x is the arc sine of 3/4. And so if I do the arc sine of 3/4, that's just hitting the inverse sine button on your calculator and getting some decimal here. You might notice, however, that that only tells you one of the points of intersection, but we saw that there were 2 points of intersection. So this is a good reminder about the function of arcsine. If we have a unit circle, arcsine says what angle gives a certain sine ratio. And all of the possible sine ratios are achieved on this side of the unit circle there. Because down here we have sine ratios that are really close to -1, all the way up here to stuff that's close to 0, all the way up to stuff that's close to +1. up until at pi over 2, when you get the biggest sign ratio, and at negative pi over 2, where you get the smallest possible sign ratio. So this one right here is the quadrant 1 answer. So how do I get the quadrant 2 answer? Is I reflect that point over pi over 2. So if I reflect it to quadrant 2, what I can do is I can do pi minus x. And that'll give me the second quadrant value. And then, yeah, so I just doubted it for a second, as happens. If I do pi minus x, I get that answer, the 2 point something. And then if I try plugging sine of that, I get 0.75. So that's just something to keep in mind, that the arc sine function on your calculator will only give you quadrant 1 or quadrant 4. Arc cosine, on the other hand, gives you the quadrant 1 and quadrant 2. All right, thanks for watching. Please let me know if you have any questions.